Hey, seventh graders, for the next 2 days, you guys are going to be working on the food lab, which is a chance for you guys to test a couple different foods that I've kind of turned into liquid form if they were not already liquid, to see if they have the presence of those macromolecules that we've been talking about for the last couple days. So fats and fatty acids, carbohydrates, which include our starches, which were the long chains of glucose, and sugars, which are our short little chains of glucose, and also proteins, which were our long chains of amino acids, if you guys remember the colored marshmallows. And that's mainly what we're going to be looking for is those four things. So fats, proteins, carbohydrates in terms of starches, and sugars. Okay? So your learning targets for today, I can test various food to determine if they contain carbohydrate, sugar and starch, proteins, and fats. So let's talk about just what these tests look like. So in this lab, you'll be testing for carbohydrates, sugar and starch, proteins, and lipids using these four tests. So we'll use the Burette test first to test for proteins. So again, you guys will do probably 2 of these today and 2 of these the next class we have. Benedict's today, to test for sugars, which is a simple carbohydrate. There's those disaccharides, so 2 glucoses put together. Iodine will test for starch, which is the big long chains of the glucose. And finally, we'll do the brown paper test, which is our test for fats, which we also call lipids. Okay? The foods that we're going to test for are right here on this little map. So you guys will have to refer back to this map several times just to kind of remember where you put stuff and kind of help you as a key, because it's sometimes hard to tell what food substance you're looking at. So we'll be testing honey, egg white, vegetable oil, flour, butter, apple juice, 7-Up, milk, and peas. Okay, on top of that, we'll also be looking at water. We're going to look at water as a control group, and I'll talk about that here in a second. And again, I've kind of liquefied all of these, so you guys will be able to kind of see them in, so for instance, I added flour, water to the flour to kind of water it down and make it something that was a little bit easier to test. Okay, so again, you guys will need to refer back to this map on slide 3 several times. Okay, let's talk about water though. So water is going to be our 10th food item that we are testing, and we're going to use water as a control. Okay, so I just want you to think about this. What does water have in it? If we are testing for carbohydrates like starch and sugar, fat, proteins, are any of those things in water? Okay, if you're saying no to that, you're absolutely right. None of those things should be in your water. Okay, and that's why we're using water as our control. So basically, if we know that none of those things are in water, it's going to show us what a negative test looks like. So we're going to have something to compare it to. All right, when I tested milk, it turned this color, but when I tested water, which I know doesn't have any protein in it, this is what it looks like. So what's the difference? Okay, I can compare them and say, this is what it should look like if it doesn't have any. What might it look like if it does have some in it? Okay, so again, water is going to be our control because we can use that. We know it's negative for all of these. It doesn't have any of these things in them, so it's a negative test. So we can use that water test to show us what it should look like if none of these things are present. Okay, so let's go ahead and take a look at what this might look like. So obviously these are just some empty vials of water. So our first test is the Burette test for proteins. So this is just plain old water in this test tube. And then we've added the Burette solution in it, which again tests for proteins. Okay, the Burette solution is naturally this kind of blue color. Notice what a negative test looks like. So if you do not have protein in your guys' sample, it should look somewhat like this. Okay, this is the brown paper test for fats. Okay, so we had a plain old paper towel. We dropped a drop of water on it and let it dry, and you can barely even tell where we put that water. Okay, and we'll talk about what a positive test for that looks like, but this is what a negative test, where no fats are in our water. That's what it should look like if there's no fat. Okay, iodine tests us for starch. Starch again is those long molecules of glucose. This is just water in this test tube, but we've added a couple drops of iodine to it here. And of course, there is no starch in water. So if you have no starch in your food substance, it should look something like this, kind of this orangish brown color. Okay, and then finally, Benedict's tests us for sugar. Those are those chains of 2 glucose molecules. Again, this is just a regular test tube of water, but when we add the Benedict's to it and heat it up, this is what a negative test is. Again, there shouldn't be any sugar in our water, so you guys can kind of see what a negative test for that looks like. Okay, let's move on. And your guys' first part, you guys will be doing either half today, so parts 1 and 2 today, and or parts 3 and 4 today, and then the vice versa the next day we have this class. Okay, so first test you guys are going to be doing, number 1 is burette test for protein. Okay, so I like to use a little alliteration to help you guys remember the results of this. So if you have protein present, your solution will turn purple. So protein, purple. If we look back at our water example, this is still blue. It did not turn purple. That means there was no protein in our water. But if your guys' food solution has protein, you're going to see it turn some shade of purple, and it won't necessarily look clear. If we're looking at milk, okay, it's not going to clear up and be purple, but the milk will turn kind of purplish in color. So you just have to kind of take into account what your solutions look like beforehand. So the liquid is a blue color. If the protein is present, it will turn lavender a color. So your hint, protein turns purple. Okay, so for those of you guys doing this at home, okay, depending on how many days you guys think you're going to be gone for, do as much as the lab. If you're just going to be gone today, then maybe just do parts 1 and 2 and expect to do parts 3 and 4 in class. Okay, if you know you're going to be gone today and the next day we have class, then you're probably going to want to do all 4 parts at home today. Okay, so your directions to this, and you guys will see me go through these directions in the video, is you're going to add 2 drops of each food substance to the wells of the spot plate. So according to this map on slide 3, so you guys will see me kind of talk about that map a couple times. Then you're going to add 2 drops of the burette solution to each well of the food. I spelled burette wrong like a real champ. Okay, and then you're going to give them a little stir with a toothpick and record your results. So what you guys are looking for at home is what those substances look like before I added the burette and after. Remember, if they turn purple, protein is present. So I'm going to go ahead and kind of show you guys how to record this. The first thing you guys need to do before you watch this video with your results is make a prediction. So you guys will click. If you think protein is in this substance, you guys will put a plus sign. Okay, we already know the results for our water. Okay, we can say a prediction that water shouldn't have anything in it, so I'm going to put a negative sign. And we in fact tested it, and you guys saw it on the picture in slide 4 that there is no protein in it. So for our actual results, we're going to put a negative sign. Okay. Honey, you guys are going to predict whether honey has protein. There's no need to look these up. These are just predictions, okay, guys? So don't worry about looking them up. If you're wrong on your predictions, that's fine. You guys are learning about this stuff, and we're going to test them and find the actual results. Okay, so again, go through, make your predictions first for honey, egg whites, vegetable oil, flour, butter, apple juice, 7-Up, milk, and peas. Which of these do you think have protein? Put a plus sign. Which do you think don't have protein? Put a negative sign. Okay, and then you guys will click right here and watch this little video. So right click it, open that link, and you're going to have to hear my boring voice drone on at, I think I filmed this around 9 last night. So a little late for me. My voice is a little... Okay, so watch that, and then as you watch it, you guys will get the results, so you guys can pause it, come back to the table, and record positives if it's protein laden or negatives if there's no protein. Okay? Great thing at home is you guys don't have to clean anything up. All right, number 2 is the brown paper test for fats. So lipids are fats. If fats are present, the brown paper will dry with a translucent color. Basically, you're going to have a grease stain on your paper towel. So you guys can see this is what a positive test would look like. And then just like when we looked at our water for our control, this is what a negative test looks like. It just kind of dries normally. You might be able to see some place where it was. But what you see with the positive test is it almost kind of makes it a little bit see-through. And we can't get it to dry, and it'll kind of stay see-through. Again, if we look back at our water example, okay, here's what a negative test looks like. It almost looks like the plain paper towel before I added the drop of water. Okay, so same thing with the burette solution for proteins. You guys can kind of read through the directions. I put a drop on the paper towel, rubbed it in, and then let it dry. You guys will make your predictions first. Again, you guys should predict that water is negative, and you should also know that from that picture I showed you on slide 4 that there's actually no water in it either, so that's also a negative test for your actual. So you guys will go ahead and make your predictions as to whether honey, egg whites, vegetable oil, flour, butter, apple juice, 7-Up, milk, and peas have any fat in them. Okay, and they might kind of have different contents of fat. You might see some that are really fatty and greasy and some that just have a little bit. Okay, and then go ahead and record your actual results there after right-clicking this video link and opening it up and watching about the fat tests or the brown paper bag test or the brown paper test. Okay? All right. Moving on to part 3, again, if you guys think that you might be back for part 3 and 4, you guys can just hold off on that so you can do the real live experience in class. Okay, you guys have a little bit more variable for your color change here. So this Benedict solution tests for sugar. Okay, so if you have any sugar in your food product, you're gonna see some color change. Most of the time it turns this orangish color, sometimes it turns this like dark orange color, sometimes it even turns green. So what you're looking for is mainly a color change from this blue color, which is the color of the Benedict solution, to some drastic change in color. And what you really have to distinguish between is what's a mixing of colors, like if we add red and yellow and it makes orange, or what is an actual change of color where you guys have white and it turns orange. Okay, so something for you guys to think about. For this one, the liquid's blue in color. One thing that's crazy about this solution is it needs to be heated up. So if you just drop the chemical into your food products, it won't do anything. It has to be boiled for a second. Okay, so if you have glucose or sugar present, it's gonna change the color. Your main color is usually somewhere in between these two colors right here. Okay, you can read about the directions. On to slide 13, you guys have this very hard to see video link, so go ahead, open that up and watch the video to look at your examples, but don't do that. Uh-oh, I think I need to fix that video. Okay. It should be a different, I'll fix it before you guys get it. Don't do that before doing your predictions. Again, we already know water is negative for any sugar, okay? And then finally record your results and then move on to your iodine test. So this test for starch. So you guys can see what a positive and a negative test looks over here. Iodine is that chemical that they might put on your skin maybe before a shot or if you have surgery to disinfect your skin. It also tells us if you have starch present, okay? So if you guys have ever gotten that on your skin, it stains orange. That means there's no starch in our skin, okay? However, if you put it on a potato, that's a different story. All right, so test for starch. Iodine is a dark rusty orange color. If starch is present, it will turn this dark black. It's a really easy change to see. It's almost a dark purplish bluish black. And if it's negative, it stays this orange color. So if you guys go back to that picture of the water as your control, you guys again know that it stays negative, so it stays this rusty orange color, okay? Just like last time, again, you guys will right click. Let's make sure I got the right video here. Iodine test. Okay, so you guys will right click, watch this video on the iodine test, and then you guys will record your actual results. Again, make sure you guys do your predictions first. Negative if it doesn't have starch, plus sign if it does have starch. Okay, and then finally you guys have 9 questions to answer, and you guys might need to kind of refer back to your lab directions and your lab info to help you out on this. Why did you use distilled water as one of your test substances? So think about why I kept kind of going over what we call the water in our experiment and what we kept doing with the water between each lab and talking about positive and negative test results. Okay, what does Benedict's test for? Again, you can refer back, that's in your lab. What does iodine test for? What does Biuret test for? And Biuret reagent will turn your skin brownish purple. Why do you think it does that? Okay, what do carbohydrates like sugar and starch break down into during digestion in the body? And why do carbohydrates like sugar and starch need to be broken down in our bodies? We talked about this a little bit in class the other day. Again, we're breaking those down into glucose, but why do we need to break it down into glucose? Why can't we just use the starch? Okay, what are proteins broken down into during digestion? And again, why do we need to break down proteins in the first place? Why do we need to have digestion? Okay, great job. Go ahead and turn it in. I'll make sure I fix that video on the Benedict's test. So if you guys are doing that at home, you guys have the right information. I hope you guys are having a great day, and I'll talk to you soon. Bye.